In today's video, I will teach you how you could make your own interactive particle system. It will look something like this. Now, what's going on here? So as you see, there are these circles that are moving around like dust, and if I hover my mouse over them, they interact by getting bigger. My objective for this video is to make you understand how you could use JavaScript to make almost anything. So what exactly is a particle system? In any video game, there is a concept of a world, and in this world there are objects. Objects can be anything: a player, a wall, literally anything. Imagine a game like Minecraft. If you have played it, after you break a block, you can see small squares fall down and disappear. This is a particle system added to each block. In this video, we will create an interactive dust particle system. You will learn how to use the HTML canvas and many JavaScript methods. Warning: there will be some math involved, but it won't be anything difficult. All you need to know is how to find the distance between 2 points in 2D space, and that physics isn't really that difficult. All you need to know in physics is that if there was an object sitting ideally, to move it around, you just need to add the velocity to its position. If you're getting turned off by this, and if you already know this, you can skip the next part because I will be explaining a bit of math and physics now. Let's take a look at the distance formula. We will talk in 2 dimensions. 3D isn't any different, so if you're 2D gang, smash that like button right now. In the 2D world, there is an x-axis and there is a y-axis. Together they form the 2D plane. If we take a look at the x-axis from point 0 to point 100, imagine that you're standing at point 0, and imagine your friend is at point 100. You are 100 units away from your friend. That makes sense even without math. Let's say your friend is at x2 equals 100 and you are at x1 equals 100. Your distance can mathematically be calculated by subtracting x2 from x1, which will be 100. If you do it the other way, you get negative 100, and you would say that doesn't make sense. Well, that's because we are actually calculating displacement and not distance. But that's not a topic for this video. Anyway, you can do the same thing for the y-axis and get the distance in the y direction. So let's complicate things a little bit. Say you were now at x, y equals 0, 0, and your friend is at x, y equals 100, 100. If you used what you just learned and do x2 minus x1, you will get the distance in the x direction. If you do y2 minus y1, you will get the distance in the y direction. If you look closely, it starts looking like a triangle is forming between the x distance, the y distance, and the real distance. Here, a will be x2 minus x1, b will be y2 minus y1. If you know the Pythagorean theorem, you can find c, which will be the square root of a square minus b square. And there you have it. You just learned something essential for game development and a lot of other things. This formula was invented by a great mathematician and philosopher called Little Pump, and has changed the way intellectuals like him who watch Rick and Morty on loop see the universe. Subscribe to cure my depression. Coming to the physics part, what we need in this project is the understanding of how things move around. To get started, we will use the x-axis as reference. Imagine Timmy here is standing still at x equals 0. His position is x equals 0. Since he is not moving, his velocity is 0 as well. If I wanted to make him move, I would have to change the velocity to something not 0. Let's say I make it 1. Now, Timmy will move 1 unit forward every second. If I make the velocity 2, he will now move 2 units every second. Now, if I make it negative 1, he starts moving backwards by 1 unit every second. What's happening here? If you think about it in a programmatic perspective, Timmy is an object with a position property and a velocity property. He also has an update function. Whenever this function is called, he adds velocity to position. If you now make a button to call this update function whenever it's pressed, Timmy will move based on the velocity we specify. This is actually how physics works when it comes to kinematics. There is also acceleration which gets added to the velocity, but we don't need that for this video. To get started with the programming, open up a folder in VS Code and then make an index.html file in there. Start by making the boilerplate code. I'm changing the title tag's value to cool circles. This won't affect anything. Now in your body, make a div with the class app, and in here, make a canvas element. Make a script tag below the app and set its source to index.js. This file does not exist right now, but we will make it shortly. It is also pretty good to have your project open on the side. I use the live server extension to hot reload my projects. That is in fact all the HTML we need. So coming to the CSS, start by making a style tag in your head. We need to set the body's margin to 0 and make the background color go dark. For the app, make it take the whole screen. And set the display property to flex. Align the items to center. And set the flex direction to column. This will set the canvas to the center of our screen. We are done with the CSS part. Coming to JavaScript, start by making an index.html file in your project folder. The first step we need to take is to call the canvas element from the DOM. So to do that, start by writing document.getElementById canvas. That actually reminds me, you need to go back to your HTML and set the canvas element's ID to canvas. Now back in your JavaScript, make a variable called canvas and set its value to document.getElementById canvas. If you log the canvas out and open your console, you will actually be able to see the whole element there. Let's set the canvas width to windows.innerWidth and canvas height to window.innerHeight. We have set up the canvas, and now it's time to set up the context. You need to tell the browser that you will be drawing something in 2D. Do that by typing variable c equals canvas.getContext2D. Your browser will now assign the variable c the ability to draw. To make life more simple, I'll store the canvas's width and height into variables called xlim and ylim. We are all set to draw. Let's draw a circle, since we will be needing it the most. The consensus when you draw anything is you put a brush onto the canvas, you move it around, and then you take it out. Same goes for this. Put the pen onto the canvas by typing c.beginPath. Take it out by saying c.closePath. Anything you do in between here will be painted as one thing. So go ahead and type c.arc in between. The values that go in here are the x coordinate, the y coordinate, the radius, the start point, and the end point, and the direction. The start and end points are for the arc, and the values in here will be in radians. If you want to make a circle, just use 0 and math.pi*2. If you set the direction to false, it will draw a clockwise arc. You also need to say fill or stroke to render something. If you use c.fill, it will make a solid circle. c.stroke will make a border. To change the fill color, write c.fillStyle and set it to red, or anything you want. You can also use both of them at the same time. This can take any color format. You can also do a stroke style to change the stroke color. Time for us to get started with the cool part. First, we will need to make a ball object. So write a function ball. The ball will have a position object with x and y values. It will have a radius and also a color. Now, let's add a function to the ball to draw it out. Let's call it show. In here, begin and close path, and make an arc with its x and y set to the ball's positional x and y, set its radius to the ball's radius, and then 0 math.pi*2 and false. Use the fill function below the arc. We will also want to change the color, so do that by setting c.fillStyle to this.color. Now, if you make a variable called ball and set it to a new ball, then call ball.show, it will draw a red circle at 0, 0. This is exactly what we want. Now that we have the ball object template ready, let's randomize some values. Starting with the position, the math.random function generates a random value between 0 and 1. If you multiply the generated value with some other number, it will give you a value between 0 and that number. So randomize the x position between 0 and xlim, and do that with the y position as well. Next, let's randomize the radius between 0 and 30. We also need to generate random colors. It will need 4 random values, R, G, B, and A. The RGB will be in between 0 and 255, and they cannot have decimal values. The alpha needs to be between 0 and 1, so that's easy to do. Also, if you notice, I'm not using the conventional string. This thing is a relatively new and by far the easiest way of using variables in string mixes. You can make it by using the backtick symbol. You type the string normally, and wherever you need a variable, you use the $sign and then curly brackets. With this, you can also do multi-line strings. To get a whole number value, type the random number function part inside mat.floor. This will floor whatever random value is generated. We are about done with the ball. The next thing we need is a world object. The world will have a size and some balls. Make a for loop and fill the ball bucket with balls. Now, if you make a variable and set it to new world, and then console log it, you can see that it got filled with 200 balls. I'm removing all the console logs from my program for now. Anyway, we have made a world with balls, but we need to see them as well. So make a function called run, and in it, we will use the for each method on the balls array to show all the balls. This is like a for loop, but makes life easier. All you do is this.balls.forEach ball some function, and in this function, call ball.show. Now if you type w.run, it will render out 200 balls. This already looks beautiful, and seems like a good place to take a pause. If you've been following along and got stuck somewhere, make sure to check all your variable names, check if you're missing a this dot, see if you set the canvas ID to canvas, and have declared the context as 2D. If you ever feel like you're lost, check my line number and that should actually give you a very good idea. Also, comment below if you don't understand anything. This will be all for today's video. In the next one, we will animate the balls and make them interactive. If you like this content, subscribe to my channel. And if you think my videos can help someone, share it. Thanks for watching. Bye.